Hello and welcome to this Unity C# tutorial where I'm going to show you how you can, like I'm just trying to do now, how you can build within a simple voxel world. So each of these voxels are just, unfortunately, cubes, Unity cubes, which we can now remove and kind of like dig with. And let's just find some brown earth as well. I also just want to show you where we dig and build will take on the characteristics of the voxel cubes situated there, like this. Here we go. And notice we can build on different sides of the cubes and things like that. So I just want to show you how to do this. Right, let's get into the code. So I'm going to disable that code that I've got working clearly, and we'll go from scratch. But I have got that code just in case I get lost as a cheat sheet. So first thing you want to do is create yourself a C# script, and then you've got to come up with a name. This is very important. I'm going to call him Diggly because you can dig around and things like this. Diggly. Okay. Now, where do we want to attach this script? Well, you could think about it as being attached to your voxel system, because you're kind of interacting with the ground and things like that. But I think because, I think about it in terms of it's something that the player or the subject does, we could attach it to the player themselves. I've called the player me. So this is just a transform with a character controller, rigid body and things like this. I've used the what do you call it? The imported one already made by Unity, found in the standard assets. So I'm going to attach my script there. I'm going to attach it at the beginning now, even though we've got no code in there or anything. One of the biggest bugs you'll find is that you've made some fantastic code, and then it doesn't work forever, and you realise you haven't attached a script. That's why it's not doing anything, and it's probably full of bugs as well. Anyway, so we've attached it. Let's go and find him. So you can double click, and that will bring you your empty code. So what do we want to do? Essentially, we want to be able to shoot a ray out of the center of the screen, so where the character is looking, and then if that ray hits the surface of a cube, we will then use that cube and its surface as a reference point to be able to build on. Or if we've hit a cube and we press the other mouse button, then we want to remove that cube. Or if we're digging into the ground, and remember we've only got one layer of voxels in our kind of Minecraft-like simulation, then we don't really want to remove that cube, because then that will create a hole in the floor. So what we want to do is just shift that cube that we've hit one down, and it'll give the illusion that we've dug a hole and we're hitting a deeper surface. And that's the beginnings of thinking about simulating Minecraft a bit more extensively. So first thing, we don't really need to start. What we do need to get hold of is the camera that's attached to our first person, because I want to know where we're looking. So we do know I want to get hold of the camera. So it's going to be a camera object, and we can call it my eyes or my camera, whatever else. Okay, so if I save this script, we should now be able to populate that variable, that public variable, with a camera. So Diggly's got my eyes, so we can go and find a camera. Now we want the camera that's attached to this first person character. So I think you can just drag that and it will find the camera. So what it's found is this component attached to our first person character. So I could have dragged the camera literally from there onto our script, but it's clever enough, Unity, to know what you want to place there. Okay, so we've got hold of our camera, so we kind of know where we're looking. Update. So this is where we're going to check whether we've pressed the mouse key. So let's use an if condition in here. If input get mouse, we want the mouse button up. That means we've done a whole click, we've pressed it. If we just use the mouse button, get mouse button, then if we're holding down the key, then it'll keep making cubes or deleting them. That's something you might want, but I'm going to go for mouse button up. just so you know what that is. And then you refer to those the first mouse button is mouse button 0, and if you want to right click, it'll be 1. So this will come in handy in a moment. So if that's true, then do this. So we want to say go and add a cube, let's say. So add cube. There we go. So that doesn't exist. So we'll make a new function, add cube, down here. Excuse me. Okay. While we're up here and doing a similar kind of thing, let's do the same for remove cube. Like that. Okay. Oh, yep. I'm going to have to write my function properly. There we go. And we want void remove cube. Functions here are void because they're returning nothing. So void just means empty of a return type, but in C# you have to state your return type. Okay, so add cube. Let's start with add cube. I think that's fairly easy to do. There we go. Well, I've done it, so I should be able to do it again. Okay, so we need a ray. If you haven't done any raycasting, this is a good introduction to it in Unity. So it's essentially doing something that interacts with the physics system. It sends out a ray, and you can dictate exactly what its vector is. That means like where it's pointing and how far it goes. And then if it hits a collider, then you can get some information back about that game object attached to that collider. So we need two things. We need a ray, first of all, and we need, we'll call that ray, and we need a raycast hit. Raycast hit, and we'll call him hit. There we go. Not wheel hit. I want to call him hit. No, stop doing that. Yes, there we go. Raycast hit. Or do I have to write physics first? Physics, raycast hit, hit. No, what am I doing? I need to go to my cheat sheet. Ray equals raycast hit, hit. Yeah, that's fine. That's fine. Raycast hit. Ah, sorry. It's it shows an error there because I haven't completed what I was doing up here. Okay, so a raycast hit. A ray. What we want to define is where it's pointing. So we're going to try and find the center of our screen where we're looking, and then go out a certain number of meters. So we're going to refer to my eyes screen to point ray. So we're going to use the screen to dictate where this ray is going to point, and then in here we need to create a new vector derived from the attributes of our screen. So let's give this a new line. It might be quite long. We want a new vector 3, and then we want the center of our screen. So we can refer to the Unity zone term screen, and then its width divided by 2. We'll have the screen height divided by 2, and for the Z component we'll just say 0. So it'll go exactly from kind of the surface of our eyes. There we go. Right, so we've got the direction that our ray is pointing in. So now we can ask if our ray hits anything. So if physics raycast, so if it hits something, then do that. So in here we basically want to add a cube. Okay, so the arguments we want to pass in here are the ray that we've defined above. We want to output to this raycast hit, which we've called hit, and the final argument is the maximum distance. So this will relate to how far away you'll be able to build things. So let's just say, I don't know, 5 meters, something like that. Okay, so I'm just going to save this. So now we need to add a cube. So we want to refer to our hit kind of like event. That will be able to return a collider to us if it's actually hit something. So we can say the new pos, or rather vector 3 new position equals the hit colliders. Or can I just go to transform? Let's see. I can go to its transform and position. Can I go to its normal? Yes, I can. Okay. So we'll say hit transform position. So what I've grabbed hold of is the cube that I've hit. I've got its position. So now we know that we can just build one block above it, or with reference to the normal. Now, a normal is 90 degrees to the surface that you've hit. So if you've hit the top of a cube, then the normal will point up. If you've hit the side of a cube, the normal will point out from the side of that cube. So that's exactly what I want. If that's unclear, you'll see what I mean now. So we can say new position, or rather, let's create our block, and then we'll move the block after that. Or shall we move this? Yeah, let's create our block. So to create a block, we say instantiate, and now we can actually refer to the block that we've hit. So if we're on like stone, we'll create stone, and if we've hit grass, we'll create grass. So we want to instantiate the hits collider GameObject. So we'll just grab the object that we've hit. So we're going to essentially clone whatever we've hit. Okay. So then we want to say, we'll give that a name. So it's going to be a GameObject. I'm going to give it a name so that we can grab hold of it. GameObject noob for new block equals that. So then we can say noob dot transform position equals our new position. So that's going to be exactly where the block is that we hit, but then we want to move it around. So we can say noob transform translate a function that can move it, this object, according to a vector again. The vector we want to use is that normal. So we're going to say hit normal times 1. So we'll just put it one block away, depending on what surface we've hit. Okay, I think that's everything we need to add a cube. Let's just run through that again. So we create a ray and a hit object. These are objects that are defined by Unity's physics engine, and we use those in the physics raycast function. So we're casting a ray that we've defined a vector for. So we're trying to point out the center of our screen. So whatever the player's kind of looking at, and we could put like a little, what do you call them? A little reticle in the center of our screen. Now we're outputting whatever collider we've hit into this object called hit, and then we're saying our ray will be 5 kind of meters or 5 blocks ahead. There we go. So then we are grabbing the position of whatever we've hit. Then we're instantiating a new block according to whatever block we've hit. So if we've hit a grass block, we'll create a grass block. Then we are saying that the position of this new block is the same as the block that we hit, and then we're just translating it according to where we hit that block. If it's on the side, we want to build it on the side. Okay, this should work. So let's save this script and just see if we've got any bugs, and if it doesn't work, I'll have a look at my cheat sheet. Let's have a cup of tea. Okay, so we've landed, no bugs yet. So let's see if we can build a block on this brown earth. Yes! There we go, so it's working. Worked first time. So we can build on the top of other cubes and on the sides of cubes as well. And that should work on whatever surface you're looking at. Okay, that's pretty good. So it works for the brown ones, and yes, we can create green ones. Fantastic. So that's it. Let's go back to our script and look. So in the update function, if we press that left mouse button, then we go to our function add cube. We're casting array and then deciding where to place our block according to what surface we hit, and using this handy normal component. So now it should be relatively easy to remove a cube. So we're going to do a very similar thing. So I'm going to copy all our raycasty things, because essentially we're going to have to do the same thing. We're going to have to look from the center of the screen, hit a surface. So all of that's going to be exactly the same. I want to remove a cube. We don't really need a new position, I don't think. We certainly don't want to instantiate an object. Now, one thing we could do, if we're on the ground, then we could translate the object one down, and that would give the illusion that we're digging. So we could do that. First of all, though, let's remove the block. So to remove a block, we use the function destroy or destroy object, and then just grab hold of the GameObject via the hit output. Okay, that should do it. So with just one line of code in there, we should be able to remove that object. Let's have a look. So I'm looking down, press the right button, aha, and our cube disappears. Wonderful. We can create holes in the earth and dig around. We can also build and remove, build and remove. Okay. Right, that's working. But it'll be much more satisfying just to begin with, and this will open you up to the next stage to be able to create much more sophisticated algorithms to think about populating cubes around the place where you've dug, so you get the illusion that you're going into the ground. We want to be able to differentiate between ground blocks, i.e. that superficial ground blocks, where we've just got one layer of blocks, and objects that we've just, or blocks that we've just created on top of the surface. So if we've created a block on top of the surface by clicking the mouse, then we want to just do this, destroy that object. But if we know that it's an object that we haven't created, then we want to just move it down one. So we begin to get that illusion of digging. So to do that, we could use tags. I'll just show you what a tag is. So in the Unity environment, if I click on, me, on our first person controller, you'll notice it's untagged at the moment, and you can select some pre-made tags. So we're going to use that component. Basically, we're going to say, when we create a cube, we give it a tag, and we'll call it something like man-made. And then, when we cast our ray to remove, if we detect that it's got that tag, that we've made it, then we want to do this. We want to destroy the object. If it hasn't got that tag, then we'll just move the block one down. That's the idea. So first we want to create the tag. So when we create our blocks, then we're going to call it I made this. So we've created our object by now. We've moved it around. And let's just say noob GameObject tag equals, it's going to be a string. We can say I made this, I don't know, I made this. There we go. I made this. Right. I'm going to copy that because we need the string exactly, I think. The capitalization is important. In that case, actually, should we just make it I made this? All lowercase. I made this. So it's easier to remember. That might be a good convention. If you're using tags, keep it all lowercase or something, as long as you're consistent with it. Okay, I made this. Now we can use that tag and say if hit collider GameObject, we can just use the compare tag function. So if it equals that, and remember it's a string, so we put it in quote marks. So if I made this, then destroy the object, because I've created it on the surface. I just want it to disappear. I don't want it to move down one. Else, if it does not equal that, so I'm just going to put an exclamation mark in front of it. If it does not equal I made this, then do the following. So here we need to be a little cleverer. We need to grab hold of the object that we've hit, which is going to be one of those cubes. So now it's going to be a ground cube. So again, get hold of, I can just get hold of the transform, I think, straight away. And then I can translate down. So to translate down, you say you can use this built-in what do you call it, like statement, built-in statement. I want to go down in terms of my direction, and just again 1 meter. So we'll get hold of it and it will move that block down. There we go. And that should be it. So I'll just run this through. So if I press the right hand mouse button, it will check the object that we've hit. If it's got that tag I made it, it will destroy the object. Else, if it hasn't got that tag, i.e. it's part of the Perlin terrain, then it will move the block down. There we go. Okay, so we'll run this. Now, this shouldn't work to begin with for a reason. Let's just have a look. To do with the tags. Okay, no bugs yet. So can I build an object? Yes. But I don't know if you've seen, down the left hand side there is an error. I don't know if my video's cut it off. But I'm right clicking now and I definitely can't delete anything or dig around. So something's gone wrong. So if we have a look at those bugs, tag is not defined. So that's the only problem really. This tag, I made this, should exist as like an object within Unity's environment, and you've got to add it manually up here to tags. You can click any object because this is kind of like a generic procedure. So if you click on any object, go to tag, untagged, and then go down to add tag. And all you have to do is add a tag. So you hit that plus bar, that plus button, and then oh no, add in, I don't know what I've just done there, add in I made this, or whatever your tag is, save. Okay, so now it's there. And by the way, if you wanted to tag things like manually out here, you've now got access to I made this, so you could select different things and give it that tag. Okay, so now things should work correctly, and we'll be at the end of the video. So walk around, I can add an object, no error message this time. So that's been tagged with I made this. And now if I right click, yes, it disappears. Okay, can I dig into the ground? There we go. So you can see now that I'm digging, it's just moving that block 1 down, which gives you the start of the mechanism that you need to create something closer to actual Minecraft. There we go. So I can dig there. That's brilliant. So I'm going to add a block on the top. Okay. So there we go. Can I build a little tower or something? Let's have a look. So if I now click this one, delete it, yep, it's deleted, it's not just moved down. There we go. Right, so that's the start of how to add blocks and remove them with two subtly different methods. Thank you very much. I hope that's helpful. Good night.